All right, welcome back to my attempt, and hopefully not pathetic attempt, to make good choices. I haven't made a automate your network video in a long time, so I think it's a good choice to keep going on this. Last video, I did say there was some stuff I needed to do between videos. That is certainly still true, but you know, might as well just do them on the video because it's just I haven't been getting super far with them, and like the struggles I'm having I think are relevant and good to include in the video. So I've been doing a great job on LPIC the last 3 days. Didn't make one today, but that's okay. Sometimes you just can't be perfect every day of the week. um and you know, an hour a day is like a good standard, and I did 2 hours 2 days ago. So like, yeah, I think I'm doing okay um, in that regard. So let's do the fun one and work on this book some more. All right, so here's my lab. Let's start it up. So I've got uh, I've got everything pretty well ready to go. All I need is to enable SSH now. Now I did have some pretty sophisticated conversations with the AI about DHCP and more actually the conversations were about DNS. So like I feel like there's some basic fundamental things about DNS that I'm kind of like not understanding. Like I did study DNS when I went to my associate's degree. That DNS was like a fairly big part of that. And so I learned about like A records in DNS, and it's just like I feel like this what I'm trying to do by setting up a DNS server, handing out DHCP addresses. It's just like it's not the way to go about this, because the thing is like you can't have uh, randomly assigned addresses like this if you want to have uh, DNS like your like a website like google.com is not a randomly assigned address. Like you can do like who is lookups on it, um and it's like, you know, these are not random sites. Or like the idea of DHCP is like here, let me ask the AI something. So okay, so when it comes to DHCP and DNS, like tell me the absolute basic fundamentals of like what I need to know, and like tell me this. So like I'm thinking like DHCP, like the reason you would do that, it stands for dynamic host uh C protocol. Oh, sorry. Dynamic host configuration protocol, I believe is what it means, but please check me on that and tell me if I'm correct about that or not. And then DNS, what I believe is that it's like domain name system is what it stands for, and it's basically like the phone book for. Oh, sorry.
You're on the right track. Let's break these down. 1. DHCP, Dynamic Host Configuration Protocol. What it is. As you correctly stated, DHCP stands for Dynamic Host Configuration Protocol. Primary purpose. It automates the assignment of IP addresses, subnet masks, gateway, and other IP parameters to devices on the network.
Right.
This way, devices don't need to have a manually set static IP address. They get one dynamically when they join the network.
Right.
Basic working. When a device connects to a network, e.g., your laptop connecting to Wi-Fi, it sends out a DHCP discover message. A DHCP server on the network responds with an offer of an IP address. The device sends back a request for that IP, and the server acknowledges it. This is often called the DORA process: discover, offer, request,
Okay.
acknowledge. 2. DNS, Domain Name System. What it is. As you mentioned, DNS stands for Domain Name System. Primary purpose. It translates human-readable domain names like www, Google, com, and IP addresses that machines use to identify each other on network. Basic working. Think of DNS as a phone book for the internet.
Right.
Instead of flipping through pages to find a name and associated phone number, your computer queries a DNS server to find the IP address associated with a domain name. To give you a relatable analogy, imagine you move to a new city, like connecting to a new network. DHCP would be similar to the post office assigning you a new mailbox number, IP address, so that you can receive mail, data packets. DNS would be like you knowing the name of a restaurant, Joe's Pizza, but not its address.
But how
You look up Joe's
does...
Pizza in a directory, or ask Global to find out the exact address. In the
Okay.
online world, the domain name is Joe's Pizza and the IP address is the exact location.
Right.
In a nutshell, DHCP provides devices with necessary IP configuration so they can communicate on a network, and DNS translates friendly domain names to IP addresses so devices can find and access websites or services by their names.
So I guess where I'm confused is like I thought that DHCP could hand out like just about any IP address to just about any host as long as it was in the pool, but it seems like that's really not the case. Like it has to hand out the specific IP address that has been designated for that host in DNS. Otherwise, the DNS record will be all messed up. Like the phone book will say that you call Gary at 555 555 5551, but you assigned Gary the phone number 555 555 5552, and unless you go back and update that phone book, people will be trying to contact Gary at the wrong number. So it's like, what's the use of DHCP if you have to like reserve IPs for specific hosts and you can't just give somebody any IP from the pool? Like, how can you guarantee that somebody gets to keep their IP or phone number in this analogy, and that when it's times out or whatever, it won't get changed and then DNS won't have the right number? Like, is there a way to automatically have DNS update, like the phone book gets the change in the phone number or in the person who is assigned to it automatically? Or is it that you have to have DNS configured a certain way? Sorry, I mean DHCP. Is it that you have to have DHCP handing out addresses in a non-random and predetermined fashion?
You touched upon an interesting aspect of networking, and your confusion is quite understandable. Let's clarify things a bit. Dynamic allocation with DHCP. By default, DHCP doesn't care about DNS. If a device asks for an IP address, DHCP just hands one out from the pool, no questions asked.
Right.
This IP might change the next time the device
Yes.
connects, depending on lead times and other factors.
Thank you.
Static allocation with DHCP. You can also tell your DHCP server to always give a certain device, identified by its MAC address, the same IP every time.
Yes.
This is called a DHCP reservation. It's like telling the post office, whenever you see mail for John, always put it in box number 5.
Okay.
DNS and dynamic IP addresses. Dynamic IP addresses, those handed out without reservations, are usually fine for most devices, like user laptops or phones. They don't generally need a fixed DNS name pointing to them. Dynamic DNS, DDNS. There's a system called Dynamic DNS, DDNS, which can automatically update DNS records when a device gets a new IP from DHCP. This can be useful for devices that need a consistent domain name but might not have a consistent IP. For example,
Yeah.
home users with changing public IP addresses from their ISP might use DDNS to always access their home network with a consistent domain name. The need for consistency. Some devices, like servers, need a consistent IP address because other devices and users depend on reaching them with the same address or domain name. In this case, you'd set up a DHCP reservation to ensure the server always gets the same IP. Then you'd manually set a DNS record pointing to that IP. Why use DHCP for servers at all? Even for devices that need a static IP, using DHCP to assign that static IP through reservations can be beneficial. This way, all IP assignments, both dynamic and static, are managed in one place. If you need to make network-wide changes, like changing the DNS server or gateway, you can do it from the DHCP server and all devices, static or dynamic, get updated. In larger corporate environment, there might be integrations between DHCP and DNS systems where specific records get updated automatically. But this is more advanced than the standard setups. So, in essence, DHCP is there to provide IP addresses, either dynamically or with a predetermined reservation. DNS translates domain names to IP addresses. In most cases, it's manually set, but it can be dynamically updated with systems like DDNS. They serve different purposes but can interact in more advanced configurations.
Okay, well, tell me how to set up dynamic DNS on my Linux machine using DNS MASQ.
Certainly. Dynamic DNS, DDNS, essentially means that your DNS records get updated dynamically whenever an IP address changes. This is particularly useful in scenarios where a
Yeah,
public IP
I
address
want
changes
that.
frequently, such as with certain home ISP configurations. DNS mask is a lightweight, easy to configure DNS forwarder, DHCP server, and TFTP server. It can be used to set up DDNS on local network. Here's how you can set up DDNS using DNS mask. Install DNS mask. Bash copy code as sudo apt-get update sudo apt-get install DNS mask configure DHCP with DNS mask. Edit the DNS mask configuration file. Bash copy code as sudo nano, etc. DNS mask. Conference add or modify these lines with your desired configuration. Go copy code domain equals your domain. Local DHCP range equals 192. 168. 1. 50,192. 168. 1. 150. 12H. This sets up a DHCP range of IPs that will be handed out to clients and specifies a local domain name. Enable dynamic DNS. Still in, etc. DNS mask. Conference file. Ensure the following line is present. Copy coded HCP authoritative. This makes DNS mask the authoritative DHCP server, meaning it can update DNS records dynamically. Configuring DNS. In the same configuration file, you can specify local domains. JavaScript copy code address equals server. Your domain. Local 192. 168. 1. 55 is statically assigns the domain server. Your domain. Local 192. 168. 1. 55. For dynamic DNS, the DHCP assignments will automatically create DNS records using the host names of the clients. Restart DNS mask to apply changes. Bash copy code as sudo system ctl restart DNS mask set up your devices. When a device like laptop connects to your network and gets an IP from the DHCP server, DNS mask in this case, its host name will be registered in the DNS. So, if your laptop's host name is laptop, you'll be able to ping or connect to it using laptop. Your domain. Local. Testing. You can check if the DNS is resolving correctly by using the dig command. Bash copy code dig at 127. 0. 0. 1 laptop. Your domain. Local this should return the IP address associated with the hostname laptop. Note. Remember that DNS mask provides local DNS DHCP services. If you're looking to update a public domain's DNS base and you're changing public IP address, like from a home ISP, you'll need a different kind of DDNS service or script that communicates with your domain registrar or DNS provider.
All right, so looking good. Sorry, I was thinking about something else. I'll pause it. I'll be right back. All right, welcome back. It is the very next day, which I love about this process. I can just pause it and come back whenever I want. So usually I like scrap the video if it's only like 12 minutes like this, but I think we made some good progress on understanding DNS better. When it comes to these things, I think, you learn about them in the textbook. Like, we know that DNS is the phone book of the internet, but it's not enough. It's like you have to see it used in like really wonky, weird ways that like the textbook doesn't know about. Like, and that's how you really understand what it does. So like, we're trying to use DNS in kind of a unusual way right now that is like not how it's set up. Like, basically what we're trying to do is dynamic DNS, I think. So like, anything you learn about basic DNS isn't really going to accomplish this objective here. So the objective is, we want to pass out IPs to all our devices through DHCP, and then we want each device accessible through its hostname that it will get through DNS, independent of the IP that it has. And what we learned about DNS is that you have to make something called A records. So what is an A record in DNS? Okay, so we'll learn about what that is.
And a record, address record, is one of the fundamental types of DNS records and is used to point a domain or subdomain to an IPv4 address. When a user types a URL into their web browser, the browser queries the DNS system to resolve the domain name to an IP address.
Yes.
If the domain has an A record associated with it, the DNS system will return the corresponding IPv4 address, allowing the browser to connect to the web server hosting the content for that domain. Structure of an A record. Domain name. The domain or subdomain you're setting the A record for. For example, com or sub. Example, com. Record type. This would be set Dave.
Yeah, so like, these A records are the entries in the phone book that it looks up. And like, how do they get there? Well, in the phone book, someone publishes the phone book, and if Ted at 555.620.5552 moves out of his apartment and gets a different number, you're going to be calling Bill at that number because the phone book never got updated. So like, that's the problem we want to deal with. So let's ask the AI about that. Okay, so here's the problem I want to deal with. So say Ted lives in an apartment and the phone book, the yellow pages, lists his number at 555 555 5555. And then Ted moves out of his apartment, and then Bill moves into the apartment. And since it's a landline, now Bill has this number and Ted does not have this number anymore. But the phone book has already been published. So when people are trying to call Ted, they're going to call Bill instead. So, like, how does an A record get created? Does it get created like the phone book, where it just once it's published is there, and if you try to contact a website, it will resolve to the wrong IP if it changes at any point? Like, how does an A record change to reflect changes in IP addressing or in named addresses?
Great analogy. Exclamation mark. In the world of DNS, the A record and other records can indeed be changed much more flexibly than the printed phone book scenario. Here's how it works. Creation and modification. When you have a domain, like example, .com, you typically manage its DNS records through a DNS hosting provider or a domain registrar's control panel. Here, you can create, update, or delete records at will. If your server's IP address changes,
so
update the
that's
corresponding route and point to
manual,
the new IP.
which we want to get away from.
Propagation time. Unlike a printed phone book, DNS changes don't take effect instantly everywhere. They propagate across the global DNS system, which is a distributed network of servers. The speed of this propagation depends on the TTL, time to live, set for the record, and other caching behaviors. If the TTL is set to 3,600 seconds, 1 hour, then once you make a change, it may take up to that amount of time for everyone to see the update. Caching. To speed up domain resolution, DNS responses are often cached by local DNS resolvers and even on end-user devices. The TTL determines how long the cache value is considered valid. Once the TTL expires, the next time the domain is queried, the local resolver will fetch the updated information. Dynamic DNS. In scenarios where the IP address changes frequently, like some home networks, you can use a dynamic DNS, DDNS service. This service will automatically update the A record whenever the IP address changes, ensuring that the domain always points to the correct IP. Potential issues. If you move your website from one hosting provider to another, akin to changing your phone number, and you don't update the A record, then yes, visitors will end up at the old server, akin to the old phone number. However, once you update the A record, given some time for propagation and caching considerations, visitors will be directed to the new server. In summary, while the initial
So, like, on the public internet, is there just a guy sitting in front of a computer updating A records all day? Like, when you're dealing with, you know, like millions and millions of addresses, like, how do these A records get updated in the real world?
No, there isn't a guy manually updating millions of records on the public internet. Instead, the process is highly automated and decentralized. Let's break down how this works in the real world. Decentralized system. The domain name system, DNS, is decentralized.
All right, and I apologize. I'll come back and play the voice, but I need to take a quick break, so I'm gonna pause it, come back, and then we'll hear the answer. All right, I'm back. Let's keep going. So yeah, and let's hear it talk about DNS some more.
No, there isn't a guy manually updating millions of records on the public internet. Instead, the process is highly automated and decentralized. Let's break down how this works in the real world. Decentralized system. Domain name system, DNS, is decentralized. While there are root servers at the top of the hierarchy, the actual details for individual domains are managed by various DNS hosting providers or domain registrars around the world. Automated tools and control panels. Most domain registrars and hosting providers offer control panels where users can manage their DNS records. When you buy a domain and want to point it to a specific IP address, you can log into your control panel and set the record yourself. Behind the scenes, the system automatically updates its DNS servers with this information. APIs. Wider organizations, cloud providers, and enterprises often interact with DNS programmatically via APIs. For instance, when you deploy a new virtual machine on a cloud provider, the system might automatically assign it a domain name and set the appropriate record without human intervention. Dynamic DNS, DDNS. For situations where IP addresses change frequently, DDNS services are used. A small software client runs on the host, a router, with the changing IP. Whenever the IP changes, this client automatically communicates with the DDNS provider to update the record. Content delivery networks, CDNs, large-scale websites and services often use CDNs, which might change IP addresses based on load, region, or other factors. These CDNs programmatically manage DNS to ensure traffic is directed appropriately. Load balancers and cloud services. In modern cloud infrastructures, services might be behind load balancers. The A record might point to the load balancer's IP, which then routes traffic to various servers. The individual server IPs might change, but the load balancer's IP and the associated record typically remain stable. Propagation. Once a change is made at the authoritative DNS server for a domain, that change begins to propagate to other DNS servers worldwide. This is an automated process. Other servers will query the authoritative one when needed, or when their cache expires based on TTL, and update their records accordingly. Redundancy. It's also worth noting that there's redundancy in the DNS system. Multiple servers often hold the same records to ensure high availability. In summary, while there's a lot happening behind the scenes, the actual process of updating records on the public internet is largely automated, with manual intervention typically limited to specific administrative tasks or initial setup.
Okay, so initial setup, administrative tasks. I don't know what that means, but there is a lot of manuals still. So I think what we're gonna focus on. So Tell me more about this idea of DNS being decentralized. Like, how can you have like multiple phone books? Like, use the Yellow Pages phone book analogy for this, because I can't imagine how you could have a Yellow Pages system that is decentralized. Like, everyone receives their own copy of the Yellow Pages, and that copy has the same entries. It's the same book copied exactly for every person. So is DNS like that? And is that what decentralization is? Or is decentralization different in that each person receives a different version of the Yellow Pages book?
Alright, let's stick to the Yellow Pages analogy to explain the decentralized nature of DNS. Centralized Yellow Pages system. Imagine a world where there's only one massive Yellow Pages book located in a central building in a city.
Oh, okay.
Whenever anyone wants to look up a number, they'd have to go to this building and check the book. This setup would create long queues, and if anything happened to the book or the building, nobody would be able to look up any numbers. This is akin to a centralized system.
Okay.
Decentralized DNS, Yellow Pages style. Now, envision a different scenario. Local copies. Instead of one central book, every neighborhood library gets its own copy of the Yellow Pages. You just go to your local library to look up a number. This is analogous to local DNS servers that many ISPs run.
Yeah.
Most of the time, you're interacting with a local or regional server, not one central global server. Authoritative libraries. Let's say there's a particular neighborhood called Webville where the businesses and residents are really proactive about updating their phone numbers. This neighborhood library is where businesses first submit their latest phone numbers. Other libraries trust the Webville library for the most up-to-date numbers, so they frequently get updates from it. In DNS, this would be the authoritative name server for a specific domain.
Oh,
Propagation. Now, if a business in Webville changes its number, the local library updates its book immediately. Other libraries might take a bit longer, as they periodically check with Webville's library for updates. This mirrors the DNS propagation delay when records are changed. Redundant libraries. What if one neighborhood's library burnt down? Well, because this is a decentralized system, other libraries still have their copies of the Yellow Pages, so people can go to a neighboring library. In the DNS world, there are multiple redundant servers, so if one fails, others can handle the requests. Caching entries. Some libraries, to speed things up, might have a quick reference list for frequently asked numbers, so librarians don't have to search the entire Yellow Pages every time. This is similar to caching in DNS. Once a number or domain is looked up, it's kept handy for a while, so future lookups are faster. Hierarchy and root libraries. There might be some super trusted libraries that don't have all the numbers but can guide you to the correct local library that does. Oh, you're looking for a business in Webville? Check out local library. This reflects the hierarchical nature of DNS, where root servers guide the queries down to the correct authoritative servers. In conclusion, when we say DNS is decentralized, we mean there isn't just one server handling all DNS requests for the entire internet. Instead, there are many servers distributed globally, working in a hierarchical and redundant manner. They frequently synchronize data, ensuring consistency, so that everyone effectively has the same copy of the Yellow Pages, while also maintaining the efficiency and resilience of the system.
Okay, so this really does it for me. So yeah, so it is the case that handing out the same copy of a Yellow Pages book to everyone is decentralization. But an authoritative named server is where you go in your local area, where like, because let's say we hand it out once, we make updates, we hand it out again, and then a third time. So we've got 3 versions out there. You know, people could still be using version 1, and that would be problematic. So, you know, for people to know, oh, are we on version 3? Is there a version 4 out? They go to their authoritative name server, and they're proactive about that. They go there. We check into it every once in a while. So that's why we need to make it authoritative in this case, so that the devices keep checking the DNS server to make sure all the DNS entries are right. So the other thing we've got to worry about is how do we get these DNS entries to be correct without manually making them ourselves. So the answer to that is dynamic DNS. Okay, so then please walk me through on my Ubuntu server using DNS MASQ how to set it up as an authoritative server and how to use dynamic DNS so that the A records don't require manual intervention to create. I want each device in my network to be able to SSH to each other device, and I want a centralized jump host to be able to SSH to each device, and I want the devices to be contacted via their host names and not their IPs. Okay.
All right.
And I'm not going to have it read this because it's we're just going to follow the guide. So, this is the other thing about network automation. It's like this, you gotta deal with this. Like, what if the network you're trying to automate doesn't have DNS on it in the way you want it? It's like, what's hard about automation is not using Ansible. Sorry, it's just so frustrating to me that, like, it's like, what's hard about automation is that, like, it presupposes a network state. And do you have that network state? Great. Okay, then yeah, get your Ansible cert and go to town. But, like, if you don't have that Ansible state, if you don't have that presupposed state that you need to apply your training and automation, you need the CCIE to come in. Like you need the networking guys to come in. So it's like this is where automation is frustrating, because, like, you have to be a CCIE network automation person, but only after you've already been a CC. Like, you have to wear a lot of hats. You can't just wear the automation hat, because, I mean, you can, presupposing a system that kind of doesn't require automation because it's already set up for it. But, if you're the person coming on board to automate it, like, you have to be able to wear that other hat and say, like, oh, DNS needs to be redesigned on this network because it will help the automation in this way. And I'm not even sure the book talks about DNS that much. It talks about the presupposed network state for sure, but yeah, we've got 8 matches for DNS. It should have a whole chapter. Yeah, it is recommended on using device host names. Okay, great. Well, I'm on the job. I read this whole book. I have a CCIE from DevNet in the automation track. They don't have DNS resolution in their network the way I need it. What do I do? Talk to the network specialist in his first week on the job? Like they should have a whole chapter devoted to anything they say that presupposes a network state, and what to do if it's not in that network state, because that's, in my opinion, the hardest part about automation is, like, not everything is perfect. And you're kind of assuming that things are like that. That's how you automate it, is you do the same thing time and time again. It says right here, cookie cutter templates. So yeah, I mean, you gotta pick what lends itself to automation and what does not, is the key. All right, so I'll pause it. I'll be right back. Yeah, so therein lies the problem with automation. Automation has a pre-requirement of a network that can be automated, which oftentimes only exists through manual methods. Okay, so yeah, let's finish setting up dynamic DNS. Okay, so there we go. So we've got that. So then, all right. So back up the. It's good. I'm glad it says that. All right, edit the file. All right, and then modify the lines. So let's look for the auth server line. Not found it. Okay, so we did do this portion here. So unfortunately, the original is not part of the backup, but that's okay. So we've got it with the net mask. I think that works. And then DHCP authoritative. All right, and then the other stuff we'll probably need to add at the bottom. This is a massive file. Yep, I believe that's it. Actually, I'm not sure. Let me try opening another terminal if that's possible. It's not possible. Well, you know what I can do? Oh, no, I can't do that either. Shoot. Okay. Go back and change it. Uh, all right. So the thing is, like, we don't need to see, we don't need to see it that way. Oh, let me system CTL restart DNS MASQ. Oh, service SQ restart. There we go. Okay. So it's dot local net. Let's change it to dot intra techness, yes, dot local. How do I jump to the end of the line? Oh, not like that. Shoot. Just spam page down on it. Tech yes. Stop local. Okay, and then cat etc grub. Oh. How do I have so what's going wrong with this? Oh, wow, okay. Oh, there we go. That looks better.
It appears. You've shown both the intended configuration values and the actual contents of your, etc. DNS mask. Conference file after filtering out comments and empty lines. Given the configuration content, here's a brief summary. You have two local directives, local equals lab and local equals tech yes. The local directive tells DNS mask to resolve names in the given domain using the local, etc. host file and DHCP leases rather than forwarding the queries elsewhere. User and group directives are set to root. This means DNS mask will run as the root user and group. The DHCP range directive specifies the range of IP addresses DNS mask will use for DHCP leases. Devices that request IP addresses via DHCP from this server will then address in the range 10, 0, 1, 0 to 10, 0, 255, 254, and the subnet mask will be 255, 255, 0, 0. Each lease will last for 12 hours, 12H, before needing renewal. The DHCP authoritative directive tells DNS mask that it is the authoritative DHCP server for the network. This allows it to immediately reclaim an IP address from a device that leaves the network, ensuring more efficient use of the IP address pool. The DHCP option equals option DNS server 10, 0, 0. 100 directive means that DHCP clients will be instructed to use 10, 0, 0. 100 as their primary DNS server. The auth server directive specifies that the authoritative DNS server for local domains is 10, 0, 0, 1 with 127, 0, 0, 1 localhost as a secondary.
How do I look at my DNS A records?
View the A records associated with a domain. You have several methods. 1. Use the dig command on Linux, Unix systems. To look up the A records for a specific domain, say example. use. The output will provide details about the query, and the A records will be displayed under the answer section.
Oh.
2.
Works.
Use the NSLookup command. Another tool that's available on many platforms, including Windows, is NSLookup. This will also provide you with the A records for example. 3. Online tools. There are many online DNS lookup tools like MX Toolbox, DNS Checker, and others where you can input the domain name and select it from record types to view the A records. 4. Check configuration files for local DNS. If you're hosting your own DNS server, the location and method to view the records will depend on the software you're using. For example, if you're using bind on a Linux server, you might find zone files under, etc., bind, zones, port, var, name. These files will have entries in format. Similarly, if you're using DNS mask, as per your previous questions, the A records might be defined in, etc., hosts or within the DNS mask configuration file.
Alright, so dig example A. So this one is .100. Yeah, I have to go and change my file. And this I don't need. Should be gposh, right? No, just leave it. I don't know what this is meant to be. I mean, I want it to be the default, so I'll just comment it out. Yep, need that. Yeah, I don't know about this one. This is where I need to change it. It's .100. All right. Looks good to me. So then we need to check with the hosting / domain provider. Interesting. Oh, okay. So yeah, that looks good. Use that dig command again. Okay, so this looks a lot better. The server is a lot better. So let's try pinging some of the. So it'd be like floor 1 dist 01 dot tech yes dot local okay, so we can feed this to the AI.
The output indicates a few problems with your DNS server configuration. The status: refused in the dig output. This indicates that the DNS server is refusing to answer the query. This is usually a result of a server configuration issue, perhaps related to allow query settings or ACLs, access control lists, in a more complex setup like bind. Since you're using DNS mask, this could be related to how the server is set up to handle non-local queries. Temporary failure in name resolution in the ping output. This indicates that the name couldn't be resolved to an IP address. It's consistent with the DNS issue you're experiencing. Server can't find FLOR01DIST01. Tech yes. Local. Refused in the NS lookup output. This is consistent with the dig output, reinforcing that there's an issue with how the DNS server is set up or how it's handling queries for the tech yes. Local domain. Let's try a few steps to troubleshoot this. 1. Check DNS mask configuration. Review your, etc., DNS mask. Conference to ensure there aren't any restrictions preventing it from answering queries. Look for no hosts or no resolve settings, which might be interfering. 2. Check the host file. Ensure that FLOR01DIST01. Tech yes. Local is properly defined in, etc., hosts if you are using DNS mask to resolve local host names from this file. The entry should look something like 3. Restart DNS mask. Once you've made any necessary changes to the configuration or host file, restart DNS mask to apply them. 4. Test locally. Test the DNS resolution directly on the DNS server to eliminate network issues. 5. Check firewall rules. Ensure that there aren't any firewall rules that might be blocking DNS queries. On Ubuntu, you can use UFW if it's enabled to check if DNS mask is refusing external queries but
Wait, so we talked about this. Yeah, I'm trying to use
to set up dynamic DNS with DNS mask, follow these steps. Enable DHCP and DNS mask, etc., DNS mask. Conference, ensure you have a DHCP range defined. Configure DHCP.DNS. Still in, etc., DNS mask. Conference, ensure you have these configurations. The expand hosts option will append the domain to host names. Client configuration. Your client should be set up to send their host name when they request a DHCP lease.
Okay.
This will allow DNS mask to create the appropriate DNS records dynamically.
Right. Okay, so that's what I gotta do, and I have to do that on the clients. So Yeah, let's work on one of these clients and then try to figure that out. So, and then we'll sniff the links as well. So like it's gonna go up through this link. It's like broadcast, so we'll sniff this link. And then let's force it to grab a DHCP address. So let's bounce that MA1. Okay, and then let's look for DHCP traffic. And we should look for we should see a discover. Okay, well I think bouncing it's not going to do it because like it doesn't wipe it out. So I think what we need to do is readdress it. Okay, so let's readdress it to like 192.168.1.1/24. Okay, and then we'll do a shut and a no shut. Okay, and now let's readdress it back to DHCP. Shut, no shut, and we should see a discover. We got it right here. So now included in this discover, and the other thing we can do that's should work. Oh, I need this. Yeah, there we go. So the other thing, I need this to be unselected and this to be selected. Okay, there we go. So the other thing we should see is the MAC address, and it's the source. So the source should match that. So let's take a look at that. Just a sanity check here. Yep. So the MAC address is the same. So then what we want to see is the host name sent. So it should be under the DHCP. Yeah, see, it says server host name not given. So we have to change the configuration on here somehow so that it does give the server host name. And we have to do that for each of the device. So DHCP server. So that's to set up a server. Like we want it to okay, so let's ask the AI.
It looks like you're working with an REST AEOS device, specifically the virtual version, VIOS. For REST AEOS devices, when acting as DHCP clients, will typically send their hostname and DHCP
really?
request by default.
Didn't happen to me.
However, the snippets you provided suggest you're in a configuration mode for the DHCP server or relay functionalities. If you want this device to be a DHCP client to get an IP from another DHCP server, then the configuration steps would differ. Let's clarify your goals. If 401 dist 01 needs to act as a DHCP client. Typically, on Arista switches, when you configure an interface to receive an IP via DHCP, the switch sends its hostname as part of the DHCP request. Example. Bash copy code 401 dist 01 hashtag configure terminal 401 dist 01 config hashtag interface ethernet 1 FLOR 01 dist 01 config if address DHCP if 401 dist 01 is acting as a DHCP server. You'd configure a DHCP pool and other relevant parameters. The server itself doesn't send its...
No, I don't want it to add as a... no, I don't want it to add it. I mean, that's one thing I could do, but I don't know. I just don't want to do that. Because I want to have like a device you can go and plug into any of the parts of the out-of-band network. DHCP relay. So I can see with Wireshark that the server hostname is not given. I don't know if that's what it means that I'm not sending my hostname. Oh wait, sorry. I actually see. Sorry, no, I see it. It actually says that DHCP option 12. No, I see it. It is sending the hostname of the device. It just doesn't have the hostname of the server it's reaching out to because it's Discover, so it doesn't even know what the server is yet. But I see that the hostname of the device is actually being sent out in DHCP option 12.
Yes, you got it right. In DHCP, option 12 is the option for the hostname. When a client, like your device, sends a DHCP discover message, it can include option 12 to suggest a hostname to the DHCP server. In most cases, the DHCP server will just use that hostname to make a DNS registration if dynamic DNS
Yeah, so, okay, so if it's option 12. Okay, so the server has it via option 12. Great. So, like, why can't I get an A record DNS entry for this device?
Given that the DHCP server has received the hostname from the client via DHCP option 12, there are several reasons why an A record might not be created for the device. DHCP and DNS integration. For an A record to be automatically created from a DHCP lease, the DHCP server must be configured to update DNS on behalf of its clients.
Yeah.
This is often referred to as dynamic DNS, DDNS updates. If you're using DNS Mask as your DHCP server, ensure that it's also set up to perform these dynamic DNS updates. Permissions, ACLs. Depending on the DNS software being used, there may be access control lists, ACLs, or permissions preventing the DHCP server from making updates to DNS. This is common when securing DNS updates to prevent unauthorized changes. DNS configuration, the DNS zone for Tech Yes. Local, from your earlier post, must be configured to allow dynamic updates. This would be a setting on your DNS server. Network connectivity. Ensure that there's network connectivity between your DHCP and DNS servers and that no firewalls or filters are blocking the necessary ports, usually TCP, UDP53 for DNS. Logs. Check the logs on both your DHCP and DNS servers. They might provide clues if there are failed attempts to update DNS records. Name conflicts. If there's already a record with the same name, Sure. Let's tackle each of these steps one by one. 1. Confirm that DNS Mask is set up as a DNS server and is set to allow dynamic DNS updates. As we saw from the previous information you posted, you've got DNS Mask configured to serve both DNS and DHCP requests. To enable dynamic DNS updates in DNS Mask, it uses the lease database to provide a rudimentary DNS service. The domain and expand hosts options are particularly relevant. This configuration tells DNS Mask to expand short names into fully qualified domains.
No, it keeps doing the thing. It keeps doing the thing. Like, I don't know. No, like, you keep doing the thing. Like, you want me to check the /etc/hosts file that it has those entries in it, but how is it going to have those entries in it? Like, I have to make those entries statically, right? What I want is that Etsy hosts file to be automatically populated. Like, how can I do that?
I see. What you're getting at.
Right.
You like DNS Mask to automatically update the etc. host file or some equivalent
well,
based
how
on
do
DHCP
I-
leases it provides. Generally, DNS Mask doesn't write it, etc. hosts directly, but instead dynamically creates DNS entries from its DHCP lease database without any manual intervention. To achieve what you're aiming for, enable dynamic DNS in DNS Mask. If your DNS Mask configuration contains the following lines. Local copy code domain equals tech yes. Local expand hosts, then DNS Mask will resolve host names from the DHCP leases it has assigned, provided the DHCP client sends its host name, which we've established yours is with option 12. DHCP lease file. DNS Mask stores its DHCP leases in a lease file, typically var, lib, misc, DNS Mask. Leases on Ubuntu. The lease file includes the MAC address, IP address, hostname, and lease expiration. Check that file to see if it's correctly capturing the DHCP lease info. Bash copy code cat, var, lib, misc, DNS Mask. Leases this lease database is what DNS Mask uses for its rudimentary dynamic DNS service without needing to write it, etc. hosts. Logs and debugging. Let's see if DNS Mask is logging any issues related to this. Pro copy code grep DNS Mask, var, log, syslog pay special attention to any entries that indicate issues with the domain name or hostname resolution. Check resolve. Conference. Your system uses, etc. resolve. Conference to determine where to send DNS queries. Ensure that it's set to use 127.0.0.1 itself for DNS lookups. Bash copy code get, etc. resolve. Conference if 127.0.0.1 isn't listed as a name server, edit. Test again. After ensuring that everything is correctly configured, try querying DNS Mask directly for hostname. Lua copy code and lookup FLOR01 DIST01. Tech yes. Level 127. 0. Thanks for providing the output. Let's address these step by step. DNS mask configuration. From the output, it's clear the domain equals tech yes. Global and expand hosts are both enabled. This means DNS mask should be handling the host names it learns from DHCP for the tech yes.
Yeah.
Global domain. DHCP lease file. The DHCP lease file does contain an entry for 401
Yeah,
1 with its
which
IP 10.
is awesome.
0. 209. 172.
Right.
This is good. Syslog. It seems var log syslog doesn't exist, which is unusual for typical Ubuntu systems. If it's a different Linux distribution, logs might be in another location or managed through a system like kernel. Try. Bash copy code journal ctlu DNS mask should display logs for DNS mask if it uses system journal. Resolve. Conference. Etc. Resolve. Conference has name server 10. 0. 0. 100 which should be correct if 10. 0. 0. 100 is the IP of the DNS mask server, your DNS DHCP server. NS lookup test. The NS lookup test failed to resolve FLOR01DIST01. Tech yes. Global. This suggests that while DNS mask has the DHCP lease information, it's not using it for DNS resolution for some reason. Next steps. Restart DNS mask. Sometimes, the simplest step can help. Restart the DNS mask service to see if that helps. Bash copy code as sudo system ctl restart DNS mask, then try the NS lookup test again. Check DNS mask's internal DNS records. Use dig to query DNS mask directly to see if it knows about the A record. Bash copy code dig at 127. 0. 0. 1 FLOR01DIST01. Tech yes. Global A ensure no other DNS service. Make sure there's no other DNS service running which might be conflicting with DNS mask. Thanks for providing the output. Let's address these step by step. DNS mask configuration. From the output, it's clear the domain equals tech yes. Global and expand hosts are both enabled. This means DNS mask should be handling the host names it learns from DHCP for the tech yes. Global domain. DHCP lease file. The DHCP lease. Alright, from the provided output, it's clear that even after restarting DNS mask, the service isn't able to resolve FLOR01DIST01. Tech yes. Global. Let's continue troubleshooting. Direct query with dig. We want to directly query the DNS mask server for an A record to check if it has the correct information. Bash copy code dig at 127. 0. 0. 1 FLOR01DIST01. Tech yes. Global A, what's the response to this? Alright, from the provided output, it's clear that even after restarting DNS mask, the service isn't able to resolve FLOR01DIST01. Tech yes. Global. Let's continue troubleshooting. Direct query with dig. We want to directly query the DNS mask server for an A record to check if it has the correct information. Bash copy, dig at 127. 0. 0. 1 FLOR01DIST01. Tech yes. Global A, what's the response to this? Ensure no other DNS service running. We want to ensure there isn't another service on the machine that might be conflicting with DNS mask. Alright, from the provided output.
I mean, we can do that. That's so see this echo command. Like what we could do is we could run a script that looks at these this file here, and then periodically, like every hour, half hour, just however long we want, it can do a redirect of like the IP that it finds, because these are all DHCP IPs. So like, this would accomplish our. So I'm gonna set that up. But I'll take a break. I'll be right back. All right, I'm back. So let's close out this this DNS nightmare journey that I've been on with a kind of dumb but effective solution, which is the kind of stuff you have to do sometimes. Honestly, in my opinion, it's like if it works, and do it. So yeah, what we're gonna do is we're gonna take we're gonna write a script where it takes the output of this here, and then it updates the host etc file automatically, and then it and it does that periodically, and then that should allow every and then the functionality of it actually being a DNS server should allow every device on the network to resolve via DNS. I think we probably will need to set up a DNS. So if we do a DNS relay, we have to do we have to specify a DNS server. So it's 10 0.0.100. Yeah, so I think we will have to put that on every single one, but it'll bring us to this network state that we desire, where we can use Ansible just with host names and without logging in. So you can see, how much of an effort, a pain in the a it is, and like when you get to a network that you want to do this on, like good freaking luck, because especially with like redesigning their entire DNS system, like their IP schemes, like they're not gonna let you do that. So like, sometimes you just have to work with what you got, and you can't do it nice and clean. But this is in the lab. This is everything under my control. So I'm gonna do it nice and clean. All right. So I guess I'll start. I'll start by just enabling, because this one has SSH on it. So I'll do the manual config. There's really no way around it. You have to drop at least the DHCP, if not follow the actual scheme and deal with troubleshooting issues if there's misconfiguration. But ideally, you can just have it configured for DHCP, and then you can deal with it in a centralized DHCP server that you have access to. That should make it easier. You have to create a user account on it. And you have to enable SSH if it's not already enabled. The other thing you have to do is put in a key. I don't see a key here. Let's try to log in. Okay, so it does have an IP address, so let's try to SSH to that from the host here. And we're not using DNS, so we don't have to worry about that. We're just using the IP. Alright, so first let's see if we can ping it. All right, we can. So now let's see if we can SSH to it with with the host name. And we can. Oh, but it looks like we've got a problem here. It's behaving in a really weird way, because we can see we are at that address. It's good, but it's ignoring this here, and it's asking for a password. So yeah, that's quite unusual. Let's try logging into the other one. This is dist 1. Let's take a look at dist 2, see what that looks like. So dist 2 isn't even configured with anything, so I think dist 1 just doesn't have the appropriate configuration on it. Yeah, so we have to put in a key. Let's do that. Alright, hopefully this works. Looks good to me. Now let's see what it looks like here. Okay, so we got it there. So I must have forgotten to... yeah, I must have forgotten to write that somehow. Let's see if it works now. Okay, there we go. See how we're right in there? So, but we still need to worry about DNS. And then the other thing is, it looks like even though it was privilege 15, it didn't put us right at the prompt. Let's see if I can change that. Yeah, so it doesn't put it right into privilege exec. All right, so yeah, I don't think, I think you just have to type enable. That's not a big deal in our Ansible scripts. We'll just have enable there. So yeah, that looks good. So the next big battle is we want to be able to ping it by the host name. Yeah, and we got nothing. So we can do that by dynamically updating that Etsy hosts folder through writing a script. But before we do that, let's just get the network to a basic state to make sure that every device has the. Basically, before we do that, let's get the what that folder looks like. To a state we want it to be in. So if we go back to the lab, this should be down now, unless it's cached. No, it's down. Okay, good. So if we go back to the lab, which is here, and then we click here. There we go. So we want to get this file to look the way we want it. We want every device to have the host name. Some don't have a host name, some have the wrong host name. And once we're there, we're good. We want every device to be accounted for. So let's work on floor 1 first. We've got dist 1 all ready to go. So let's do dist 2. And unfortunately, this is, as I said, kind of the frustrating. And this is where it gets upsetting too. Is like, oh, automation is supposed to be this great thing. Well, automate this. Like, good luck. Okay, so here we go. That's the host name. So now we need, oops, ouch. Okay, so now we need the IP address DHCP. Okay, and then username Shiposh. No password. Username Gposh. SSH key. Okay. SSH. Okay, so there we go. We're good to go with that. So we've got we should see that update now in the leases folder. We might need to have it pull a. Oh, yep. So we didn't even have to have it pull a new lease. It just automatically updated. Oh, it's actually because the Discover got sent through. Um, because we enabled the port for DHCP, so we got a new Discover here. Option 12. Uh, yeah, option 12 here, and it's included there. Okay, so we don't need this open anymore. Sometimes, it just floods up. Oh, my blood pressure is... Oh, it looks good. Okay, so I don't know, my blood pressure monitor randomly came on. So let's see here. That looks good. Yep, so we got to go through and finish all of these. Oh, this one already has a host name. Oh, okay. Well, that's interesting. Oh, you know what? I forgot to cable. Oh no, I didn't. Well, what is going on with that? Link state is down. Link state is still down. All right, so let's try deleting and re-adding. I mean, sometimes you have to do that. It's just a thing with GNS. Still down. Okay. Wow, that's confusing. Why is it not coming up? Okay, there we go. Perfect. No shut. Oh, that's interesting. The link state is up on a lot of these. Link state is still down on the management port, though. See, I feel like I'm not actually plugging it into the management port. Like, I don't know which port is the management port. It could be the last port. Let me try that. Huh, it's not the last port. All right, so let me try. Shoot. I'll just try configuring each port for DHCP. Um, that's interesting. I don't see the ability to put an IP address on it. Maybe because it's in a range. That probably makes sense. Because you can't really put all the same. Yeah, now it's here. Okay. Ow. Wait, I can't put DHCP on one of these? I'm so confused. Oh, IPv4. Oh, no, that's not it. Shoot. Ow. Yeah, I don't know how to set it up for DHCP. Yeah, I think maybe it's a configuration thing. I wonder if there's a way. So there's 9. Uh, I can't. Yeah, I don't know. All right. Well, that's a problem. I can't get the management port on this up. I mean, guess I wouldn't have to use the management port, but it looks like I've never seen this before either. It looks like you can't put a DHCP address on a non-management port, which is like, why? That seems kind of ridiculous. Yeah, so we can't have DHCP on any port but the management port. But the management port we can't bring up. Let's see if it's down on this one as well. Okay, so it's up on this one now, which is good. So let's configure this one, and then we'll come back in another video, um, configure all the rest of them and then t-shoot this one. It might just be a matter of deleting it and recreating it, because this one is good, so that's good news. Now it is a problem that it definitely is a problem that we don't have the IP showing up here. I think we do need to do like a domain name. Or no, we need to do a DNS server. Yeah. Server address. Oh, we could do VRF. All right, so let's look at the. I'm surprised it's not showing up in here. Let's see what address it was again. All right, so it's 112.145. .45 or .145? I can get rid of these. Oh, I wish it would stop asking me that. Yes, that's why I clicked on the X. Okay, so it's .45. So it's so it's this one here. I think it needs to be shut down and then brought back up. Let me try it. And I think it needs to get an IP of like a random IP static, and then like that one would have won /24, and then IP DHCP. Should do it. Hopefully. We're not. Man, that's rough. Let's capture the discover. All right, let's capture the discover. Oh, 82. I want option 12. Okay, here's the discover we're looking for. So let's see what option 12 says. Yeah, see, if we don't have option 12. That's what's going on. So, like, how do I enable option 12? Maybe they just don't all have option 12. Yeah, we still don't have option 12, so yeah, like, see what I mean? It's like, oh no, we do have option 12 right here. Why is it not oh, we have a vendor class identifier. No, see, we don't have option 12. We have option 55, which is a parameter request list. So it's like requesting the host name, but like it's not giving it. It's just like what the options are. Man, why is it not giving option 12? Can I ask the AI about this? Select all, maybe? I wish I could just select this. Like I wish I could just copy the text. So why isn't this Vice? Why isn't this device sending option 12 in its DHCP discover?
In the DHCP protocol, the option 12 represents the hostname. From the packet capture you provided, it's clear that the device in question is not sending its hostname as part of the DHCP discover packet.
Do it, please.
To answer why it's not sending option 12, we need to consider a few possibilities. Device configuration. Some devices don't send their hostname by default. The configuration on the device itself determines whether it includes its hostname in the DHCP discover request. The device may need to be configured to do so. Vendor-specific behavior. The DHCP discover packet includes the vendor class identifier, option 60, which in this case is identified as Aruba ABC 100.3 Aruba OS. Vendor-specific implementations of DHCP might not always follow the same behaviors. For instance, certain versions of Aruba OS might not send the hostname by default or might require specific configurations. Previous network behaviors. If the device has been previously configured or has interacted with other networks, there might be some cached or saved network settings influencing its behavior. A reset of network settings, if feasible, might alter its DHCP behavior. DHCP server behavior. Although it's the DHCP discover packet you're looking at, remember the DHCP is a multi-step process. If the device had previous interactions with the DHCP server that led it to believe it doesn't need to send its hostname, it might omit it. This is a less likely scenario but worth considering. Device limitations. Some embedded devices or devices with limited software capabilities might not send their hostnames simply because they lack the feature to do so. To determine the exact reason, you'd ideally look into the documentation or configuration settings of the device itself, in this case, something running Aruba OS, to see if there's any mention of how it handles DHCP option 12. If the device is under your control or administration, checking its network settings or configurations for DHCP behavior would be the next step.
Yeah, okay. How do I do this? Oh, okay. Here it is. Perfect. Got it. Oh, what? Ambiguous command. Oh, I don't have that command on it. Wait, what? Yeah, I think this just doesn't have it, because if it had it, it would have this command on it. Well, that's too bad. I needed that. Yeah, I don't have this. I don't have it. Man, that's too bad. Well, so much for my idea. That would have worked perfect. I mean, I guess we just can't have dynamic DNS in any way. In any way, we could do it from LLDP information. That would be kind of cool. Oh, we could definitely do that.
It appears that LLDPD, the LLDP daemon, is not installed or not in your system's path. LLDP, Link Layer Discovery Protocol, is a standard protocol used by network devices to advertise their identity, capabilities, and neighbors on an Ethernet network. The LLDPD is a software package that allows you to run LLDP on Linux-based systems to discover devices directly connected to your system. If you wish to use LLDP, you'll need to install it. Here's how you can install and use LLDPD on a Debian Ubuntu-based system. Install LLDPD. Bash copy code as sudo apt update sudo apt install LLDPD start the LLDPD service. Bash copy code as sudo service LLDPD start verify LLDP neighbors. Bash copy code LDPCLI show neighbors. This should provide you with information about devices directly connected to your system that are also running LLDP. Remember that for LLDP to be useful, both sides of a connection should have LLDP enabled. So, if you're trying to discover a device connected to your system, that device also needs to have LLDP running.
All right, so I'm not sure. I mean, it takes a little bit of time sometimes for it to come up, or for there to actually be LLDP, and you have to enable that as well. Oh, you know what? This. I think this device is not hooked up. Oh no, it is. It is. So like, why can't I get LODP on that? All right. Well, I'm kind of done with this. Yeah. So we tried to set up an automated method to where if we wanted to install a new floor, basically all we'd have to do is drop all the devices, and then we'd get DHCP, it would get DNS for this, and then all we'd have to configure are like the host name keys, and yeah, that's pretty much it. Like the user account, make sure SSH is on there, wire it up correctly. But unfortunately, it's just not working. And since you have to configure that stuff manually anyway through like a console connection, it's just not worth it just to save like a few lines of configuration. Like your techs know what they're doing; they're gonna get it right. They probably know more than you do. So yeah, that's it for this video. The When we come back, we'll work through device by device again, get everything up and running. But we'll do that in another video. Thanks for watching. See you in the next one.